is going to take a quick look at simultaneous linear equations again. But we're going to look at a third technique, as some people can find the other two a little bit tricky to use. So this technique might be more for you. So let's take this example simultaneous equation. It appeared in one of the previous videos, where we've got 3x minus 4 equals 4y minus 10. And 4x plus 1 equals 2y plus 3. And we are being told that these are simultaneous. And if you remember, that what it means is the x's are the same value and the y's have the same value. So provided we know that, we can use simultaneous linear techniques. Now in this technique, what we need to do is make either x or y the subject of the equation. Now, we don't have to get the x on its own, the x as with a coefficient of 1. So in other words, we don't need x to have no number in front of it, but we do need to get any numbers that are being added or subtracted, or we need any other variables to be shifted over. So in this case, I want the 3x on its own in the top equation and the 4x on its own in the bottom of the equation. So first job is to move the 4 over in the first equation, and it becomes a positive, as we know, and I'm going to move the 1 over to become a negative. So I'm left on the left side with only x's, 3x and 4x, and note that all the x's have to be on the one side of the equation. And you can do this just the same, you can do this with y's as well. I simplify that because by taking the 4 over, minus 10 add 4 gives me minus 6, and by taking the 1 over, 3 add minus 1 gives me 2. So now I've got a nice simplified equations. What is my next step? Well, I want to make the number of x's the same in both equations. So to do that, just as I showed you in simultaneous linear equations technique 2, I'm going to multiply this whole equation by the number that's in front of the x in the second equation, and I'm going to multiply the whole bottom equation by the number that's in front of the x in the first equation. So in this case, 4 is in front of the x in the second equation, so I'm multiplying the first one by 4. And 3 is in front of the x in the first equation, so I'm multiplying the second one by 3. So it becomes 12x because 3 times 4 is 12, 16y because 4 times 4y is 16y, minus 6 times 4 is 24, and then 3 times 4x gives us 12x, 3 times 2y gives us 6y, and 3 times 2 gives us 6. Remember, everything that's separated by a plus or a minus has to be multiplied by the number we are timesing. Now, the important thing to realize here is that the number of x's is now identical. So what we are saying is the 12x could be 16y minus 24, or just the same value, it could be 6y plus 6. These two equations, 16y minus 24 and 6y plus 6, have the same value, the value of 12x. So what I can do is replace one of the 12x's with just get rid of the 12x and just replace them with the two equations including y's. So instead of having a 12x in here, I've put 16y minus 24 because I know that is equal to 12x, that is the same as 12x, and 6y plus 6. So put the two y sides of the equations either side of the equals, and now we've got rid of the x's. And the important thing here is we only have y's and numbers, and we're back to basic solution of algebra. I can move the 24 to the other side of the equation and the y's to the left side of the equation, simplify down to 10y is equal to 30, and then divide by 10 to simply give me y is equal to 3. I now know the value of y. I then take one of the old equations, either one, it doesn't matter, substitute in the value of y, which is 3, so 4y becomes 4 times 3. Simplify down, 4 times 3 is 12. Move the 4 over and do our little takeaway here. So 12 take away 10 is 2. Moving the 4 over, it becomes positive. So 3x is 6. Divide both sides by 3. And now x is equal to 2. And as we said, y is equal to 3. Those last two bits done fairly quickly there because that's solving algebraic equations, which we've done so far. So that's a third technique with simultaneous equations. Make the value of the x's, or the number of x's, or the number of y's equal on one side of the equation so that it's on its own, and simply replace the x's with the equations that the y's are in, or if you've or the reverse argument if you've chosen to do it with making the y terms the subject. So whichever simultaneous equation technique you find easier, use that method.